Hi, so this session is on using the x and y intercept method to draw a straight line. So there are two other methods we have covered. The first method was using a table of values. Second method we looked at was using the gradient and the y-intercept method. And this method here, we have to simply follow two steps, and that is you either find the y-intercept and then you find the x-intercept. That's all you have to do. And to understand how to find the y-intercept and the x-intercept, let's just look at a quick graph. Now, looking at this graph here, there's no line on it just yet, but we know that if I had a point, just say on the y-axis, say there was a point there, at that point, if it works, so at that point there, we can see the y value is 3. So looking at this, the y value is 3. What is the x value at this point? If we go down, the x value you can see is 0. It hits the origin. So for this point here, we would say, well, x is 0 and y is 3. So any point on the y-axis, any point we put, x is always going to be 0. And the same thing happens for the x-axis. If we have a point on the x-axis, just say we had a point here, x is positive 4. At that point there, we know if we had to plot a point like this, y would be, if we go to the y-axis, what's y? Y is 0. So this point here, x is positive 4 and y is 0. And we know when we plot points, the trick is whenever you see a 0, for the x or y value, you know straight away your point will be somewhere on one of these lines. So if x is 0, it'll be on the y-axis somewhere. In this case, y was 3. There's a point right there on the y-axis. And if y is 0, our point will be somewhere on the x-axis. Okay? And that's something you have to remember. So if we actually draw a straight line now, and it's supposed to be straight, now, looking at this straight line, we can see it's passing through, there are two intercepts. So intercept, if you're not sure what that means, the intercept is like an intersection. Where does the line touch the y-axis and touch the x-axis? Or where does it cut through? Well, we can see there's a point here where it cuts through on the y-axis. Oops, sorry. And there's also another point here where it cuts through and on the x-axis. So there are two intercepts, or you could say intersections. And we are going to use that third method by finding these 2 points, and then we simply plot these 2 points and draw our straight line. And so at this point here, it's really important you understand at that point, the y value is 0. And at this point here, the x value is 0. Okay, so it's really important to remember that because we'll be using this concept. When y is 0, we find our x value. In this case, it's -2. When x is 0, we can find our y value, which is +3 here. Okay, and so we are finding the intercepts. The x and y intercept method means finding the points where the line cuts through the y and x axis. Okay, so for our first question, we're being asked to draw this linear equation. So we know this linear equation is actually a straight line when we draw it on a graph. To draw this, and we have to use the x and y intercept method. Okay, so we have to use this method here. And if a question specifically asks you to use a certain method, you must use it, even if you don't like it. All right, so our first step, if you remember, is to find the y-intercept. So if you have a look at this equation, we know if an equation is in the form of y equals mx plus c, we know m is the gradient. What is c again? C is the y-intercept. And have a look at this. We can straight away look at and see what is the y-intercept. The y-intercept is -4. So if I was to quickly draw a sketch of this line, I'd have -4 down here on my y-axis. Okay, the line is a positive gradient, so it cuts through that point and goes up. There's the y-intercept. That's the point where the line cuts through the y-axis. But we now have to find the x-intercept to finish the method. Now, to show working out for this, to prove that the y-intercept is actually -4, what we do is we can write step 1, if it helps. Oops, so step 1. Okay, so the y-intercept, we can write it short like this. Y-intercept when, remember at that point, it's when x is equal to 0. So we're going to now use substitution to work this out. So when x is 0, get your equation and make x equal 0. So y equals 2 times 0 minus 4. What's 2 times 0? We know 2 times 0 is 0 minus 4. And 0 minus 4, we are left with minus 4. And there we have it. So when x is 0, y is -4. And then you can write this as a point. So the final thing is, the point is, when x is 0, y is -4. And then we can plot that point on our graph later on. But that's just a rough sketch here. We now have to find the x-intercept, and to do that, we know at that point, y is 0. So let's now do that. Okay, so our second step, so step 2 is, sorry, we're finding the x-intercept. So we're finding the x-intercept when, this time, y equals 0. So this one here, unfortunately, when we have an equation like this, y equals mx plus c, we cannot see the x-intercept. So we always have to have some working out when trying to find the x-intercept. So now when y is 0, get your equation. Where's y in the equation? Here it is. So we have 0 equals 2x minus 4. And now all you have to do is solve this equation. It's quite easy. Now if you don't like x on this side, we can rewrite it like this. 2x minus 4 equals 0. And now we simply put minus 4 on both sides. Oh, sorry, plus 4 on both sides. So it cancels out here. And plus 4. So we have 2x equals 4. And our final step, simply divide by 2. Cancels out and divide by 2. And now, last of all, what's 4 divided by 2? It's 2. And there we have it. What have we just found? We have found the x-intercept. Because when y is 0, we made y 0, it tells us what the x-intercept is. Okay, and x is positive 2. So the point will be when x is 2, y is 0. Always write that final point there. So now let's go to our graph and show where these points actually are. So now we found the y-intercept. When x is 0, the y-intercept is -4. So let's show that point on our graph. So we've got -1, 2, 3, and 4. There it is. That's one point. The next point we found was the x-intercept when y was 0. So the x-intercept is 2 when y is 0. There it is. At that point, x is 2, y is 0. And now our line, you get it's a bit hard to use a ruler on this. So imagine I got a ruler. We simply draw our line passing through those 2 points, and that's it. Done. And of course, write the equation next to the line, and we're done. And if you wanted to, you can show this point like this. See how we put the y-intercept as a point? You can write it like this. So at that point, x is 0, y is -4. And at this point here, x is 2 and y is 0. So it's a good idea to put those points to show that you have found those points. Okay, question 2. There's our equation. Looking at our equation, we can see the gradient is negative and the y-intercept is -5. So always analyze your linear equation before trying to draw it, so you can have an idea on what it will look like. A quick sketch, but based on the information we have from this, we know it's going down the hill because it's a negative gradient. We can see the y-intercept where y is -5. So that's where the line cuts through. A negative gradient, so our line will be coming down this way and passing through that point. So just looking at this equation, that is what you should be picturing in your head, in your mind, because we can see the gradient is negative, down the hill, y-intercept is -5. We haven't found that x-intercept, that point right there. We have to find that next, and then we can draw a more accurate graph. But so far, that's what we have at this stage. Okay, so I've got my 2 steps here. Now, step 1, it doesn't matter which step you do first. You can find the x-intercept first, or you can find the y-intercept first. Now, this question is from a worksheet, and on the worksheet, they have that they've asked you to find the x-intercept first. So you can go ahead and do that first. Doesn't make a difference. Now, with the y-intercept, like I said, we can actually see it. The y-intercept is -5. To show some working out, so the y-intercept is when x is 0. So we make x equals 0. So we have y equals -0, or -1, or minus times 0, -5. That's just 0 here. So y equals -5. So the x-intercept, that point is when, so the y-intercept, that point is when x is 0 and y is -5. Show it as a point. Done. Now, the step 2, we have to find the x-intercept, and that is when y is 0. So we make y equals 0. So 0 equals, now we've got -x -5. And now we just have to solve for x. So if you don't like having 0 on that side, we can just put it on the other side. We haven't changed anything. And now let's just solve this. So we've got -5 here. So we've got -x. So we +5 on both sides, +5. So -x equals 0 plus 5 is 5. And that negative here, we can divide by -1. So divide by -1, that cancels out. And we end up with a -5 on that side. So the x-intercept is when x is -5. And to show it as a point, so ready? X is -5, and at that point, y is, remember, y is 0. And we're done. And now all we have to do is plot these 2 points on a graph and draw our line. Let's go and do that. Okay, so there's our equation. We found the y-intercept. So the y-intercept is when y is equal to -5, and the x-intercept is when x is equal to -5. So they both are the same value. Now, so let's find these points when y equals -5. Where is it? Y, it's down there. There's that point. And when x is -5, go to the x-axis. We haven't labeled our axes, y and x. So x-axis, there's -5 on the x-axis. Plot our point, and now get a ruler and join these 2 points up. Whoop, there we go. Sorry, it's not straight. And imagine that's a perfectly straight line. It's passing through these 2 points. We can see we have a negative gradient, and we're going down the hill. So we can see the gradient is correct. And now, last of all, show these points using actual coordinates. So when x is at this point here, x is -5, and we know y is 0. At this point here, we know x has to be 0, and y is also -5. And we're done. Okay, our next question, here it is. So before we even start using any method, we first analyze what we have. It's in the form of y equals mx plus c. The gradient is a +9. The y-intercept is -3. A quick sketch of our graph will show us this. We're going up the hill, and it's cutting through when y is -3. So it cuts through that point, the y on the y-axis, that's the y-intercept, goes up the hill like that. So that's roughly a quick sketch just based on what we have here on our equation. That's what our straight line is going to look like. And we can see the x-intercept is going to be a positive number. So when we work this out, and if we end up with a negative x value, we've made a mistake, because we can clearly see x has to be a positive value. Okay, so here are our 2 steps. So step 1, find the y-intercept, and we can see the y-intercept, so there's not much working out there. And step 2, find the x-intercept when y is 0, and we're done. So when x is 0, let's show some working out. I know we can see what it is, but let's just show some working out. So when x is 0, y equals 9 times 0 minus 3. 9 times 0 is just 0 minus 3, and 0 minus 3, we're left with -3. And there's our y-intercept. And show it as a point. So when x is 0, y is -3. And we will plot this point soon. Now, our next step is to find the x-intercept when y is 0. So get your equation again, and this time make y equals 0. So 0 equals, and we've got 9x minus 3. Now we can write it like this, 9x minus 3 equals 0, if you like having x on this side. Our next step is to plus 3 and plus 3, that cancels out. So we have 9x equals 3, and then divide by 9, this cancels out. Now we end up with a fraction for this one. It won't divide evenly. So simplify your fraction. So x equals, well, 3 divided by 3 is 1, and 9 divided by 3 is 3. And we end up with a third. And that's fine. Sometimes our intercepts can be decimals. Now, a third can be written as what? If you put it in your calculator, 1 divided by 3, it can be written as this, 0.3333, or a dot on top. So it's important, when you do have a fraction, get your calculator and see what the decimal is so you can then plot the points. In this case, we have to go and find where 0.3 is. Okay, so we've got our graph here. So we found the y-intercept when y is -3. So go to the y-axis, find -3 and plot the point right on the y-axis. And we know here x is 0. And the x-intercept is a third, or to have a decimal value, it's 0.33333. And let's just approximately find where 0.3 is. Now, obviously, we won't get the exact point, but it's pretty close. So it's halfway is just there, so I'll go a bit below 0.5, so about there. Whoop, that didn't work. And approximately 0.3 is just here. Okay, so now all we have to do is get a ruler and join these 2 points up. And make sure you pass through those 2 points. Now, I'll try that again. All right, that's the best I can do. All right, so you can see it passes through 0.333 and -3. So now please show these points like this. So at that point there, okay, x is, you can write 0.3 with a dot on top, or we'll leave it in fraction form so it looks neater and more accurate, I guess. And y is 0. And then here, x has to be 0 and y is -3. Okay, and you can write your equation on your graph as well. And you have clearly shown the 2 points you have found. This here is the x-intercept. This down here is the y-intercept. Okay, our next question from that worksheet, we've got this equation here. So you should be getting the hang of it by now. The 2 steps are find the y-intercept when x is 0, find the x-intercept when y is 0. Y-intercept, we can see what it is. I'm not going to do working out for this one. We can see that the y-intercept, c, is -2. So we can say y will equal -2 because when x is 0, we'd have -4 times 0, which is 0. All right, and we'll show it as a point. So we have when x is 0, y is -2. There's a point we have to plot on the graph. And now, next step, find the x-intercept. So we know for this one, we can't see the x-intercept in our equation. So now it's when y equals 0. So if y is 0, we have 0 equals -4x minus 2. And of course, if you don't like 0 on this side, I can just put it on the other side. We haven't changed anything. And now, instead of -2, we have to +2 here. It's gone. And +2 there. So we have -4x equals a +2. And our final step is to divide by -4. That cancels out. And divide by a -4. So finally, we'll just fit it up here. X will equal to, we can see it's going to be a negative, simplify it, a -1/2. Or you could say -0.5, just so you know where to plot it. So now we will write this as a point. Okay, so we've got x is -1/2 and y is 0. So now let's go and plot these 2 points on a graph, and then we can draw our straight line. Okay, so now let's plot these points we have found on a graph. So the y-intercept is here, x is 0, y is -2. Let's plot this point. X is 0, y is -2, here it is. And next, the x-intercept is -1/2 or 0.5 and y is 0. So now go to -1/2, so on this side of the x-axis, and there's -1, so -1/2 will just be here. Whoop, that didn't work. And just remember, it's not here, that's -1.5, so -1/2 is here. And now get a ruler and join these 2 points up, and we're done. So it's not going to work. I'll try my best. There we go. That's why you use a ruler to have a straight line. It's passing through the x-intercept at -0.5. It's passing through the y-intercept at -2. And now show these points. So we can clearly see what you have found. So the y-intercept, x is 0, y is negative 2 at that point. And here we've got x is negative a half and y is 0. And you can write your equation next to your line or on the graph, y equals negative 4x minus 2. And we're done. So hopefully you have gotten the hang of this. It's not that hard once you keep practicing, but please make sure that you practice all the methods. And this one is actually, I think, the hardest method to get the hang of, but it's not that hard once you get the hang of it. Thank you.